Hello, this is Math and Metacognition, an approach to improving math explanations. My name is Melanie Fainel. I am a third grade teacher at Brecht Elementary in the Manheim Township School District, and I'm currently finishing my master's degree in assessment, curriculum, and teaching and education with a STEM concentration at Millersville University. The inspiration behind my research project stemmed from my students' below basic scores on our district math benchmark assessment. My main focus was on the open-ended portion of the assessment, where I noticed my students struggled with the math explanations. They had a difficult time explaining how they solved the problem and why they took each step to solve the problem. I also noticed that my students had a hard time creating a pictograph using a frequency chart, as well as solving two-step word problems. These three areas gave me the focus I needed to base my research for the next several weeks. With this action research project, I hope to answer the question, how will consistent self-reflection of math explanations impact student responses to word problems over 3 weeks? Based off the research on similar topics, I found 3 common threads when it comes to metacognition within math: positivity, strategies, and reflection. Koska and Wilkins found that positive internalized feelings about math affected students' autonomy, relatedness, and math competency during math discussions. Once students have that positive internalized feelings, it's important for the teacher to create strategies to help students with their metacognitive abilities. Frederick et al. Analyzed ways to help students build their metacognitive abilities through the use of a Foursquare graphic organizer and scaffolded groups. Collaboration and confidence stem from this type of organizer. Talk conducted a similar study by implementing a know, want, learn, or KWL chart within math instruction to see if they would help with math performance. He found that the reflecting before and after a unit helps students build a deeper understanding of math content. And going off of that, it's important for students to take time to reflect on their learning. Smith and Pearls studied 8th graders who wrote in a diary before and after completing their homework for several weeks, and they found that students who took the time to reflect on their areas of need and successes had better self-efficacy and self-regulation skills. They also found their math scores improved as well. So to conduct this research, I did it in 4 steps. First, I gave my students the pre-test, which was the open-ended question from the district benchmark assessment. Second, I conducted a series of explicit lessons that looked at metacognition and written math responses. Third, I gave students 2 graphing open-ended questions a week, which focused on having students work on their graphing, two-step word problem solving skills, and creating a written response. The last step was to give students my post-test, which was the open-ended question from the first step. So for weekly graphing, students were working on representing data from a frequency chart by creating a graph, whether it was a line plot, a bar graph, or a pictograph. They then had to solve a 2-step word problem using the data from the graph and then explain how they got their answer. While students were completing these math tasks, they were to use this checklist to see if they were completing all the steps they needed to solve the problem. This is the metacognitive step. So students had to make sure that they showed understanding of the problem by boxing numbers, underlining important information, circling the question, showing all their work, circling their answer with a label, making sure they explain each step that it took to solve the problem within the explanation, and make sure in the explanation they explained why they did each step to solve the problem. So how I collected data from that was students received 1 point for every element included from the checklist for a possible total of 5 points. That was from the previous slide. Students could then earn an additional 1 point for the correct mathematical answer to the problem. I saw improvement with all students from problem to problem, but by the end of the graphing problems, I only had 14% of my students who were able to score a 6, which means that they did all the metacognitive strategies using the checklist and they got the correct answer. Then I'm going to compare the pre and post test results. So the first thing I looked at was their graphing skills. With the problem, students were asked to create a pictograph of data collected from a frequency chart, and it looked at cookies bought within a week from the cafeteria. So students could earn a possible of 2 points with the graphing. They could earn 2 points if they got everything correct. They could earn 1 point if a minor error was impacting one day, so maybe they did everything correct except for maybe Tuesday. Or students could earn a half a point if they had the correct numbers represented, but maybe it wasn't a pictograph, it was a different graph instead. The correct numbers were there, but they didn't follow the key of a circle equaling 2 cookies, or they had only one day that was correctly represented on the pictograph. So I saw that 92% of my students showed improvement from pre-test to post-test, and by the post-test, 79% had correctly made a pictograph. Next, I looked at the explanations from pre-test and post-test. In this portion of the assessment, students were asked to compare the amount of cookies bought from one week using the frequency chart to the next week. They were given the amount of cookies that were bought the next week. And then they had to explain their reasoning or their answer. So students could earn a possible 2 points for this portion of the assessment. They could earn 1 point by getting the correct answer of 19 cookies. And then when it came to the explanation, students could earn 1 point if they had all correct work or an explanation that was complete, or they could earn a half a point if they had mostly everything correct, but there was maybe an incomplete explanation or a minor calculation error. From pre-test to post-test, I found that 35% of my students showed improvement. I had 21% who did worse, and 42% correctly found the correct mathematical answer, which was the 19 cookies. And of those 42%, 83% were able to provide the steps that they took to solve the problem within their explanation, but they did not explain why they took each step. So as I look at the data, I come to 4 conclusions from this research. The first thing I think about is time. 3 weeks was a very short amount of time to work on metacognition. So this is something looking ahead to next year that I definitely want to start right away with my students. They need time to know what metacognition is, have practice with it, and then hopefully throughout the year they'll get better and better and they'll show with their math. The other thing too was making sure I focused on one skill. With it being close to testing time, I thought this project would be great because I was killing 3 birds with 1 stone, getting it all in before testing, but I realized since there was so much material that students struggled with, the graphing, the 2-step word problems, and the explanation, that the strategy was not as effective as I would have liked it. So next time, maybe if I use the skill, just focus on one math aspect at a time. The other thing too, going along with time, is that students need practice. They need practice mastering the math skill, and they also need practice using the checklist as well and reflecting on how their work is compared to what the expectation should be. And going along with that, I would like to give my students more specific feedback. I would like to set times next year to meet with students and have conferences and look at their work compared to their metacognitive paper and set goals with them, come up with some improvements and things that we can work on and strategies to help them improve throughout the school year, which will be beneficial for not only me, but I think my students as they're taking ownership in their learning, which is a big part of that metacognitive as well. So, thank you for listening to my presentation. If you have any questions, please feel free to email me at the address below. Thank you.